Welcome back, everyone. Today, our goal is to identify and model points, lines, and planes. This is in Chapter 1, Section 1 of your book. First, we are going to review some vocabulary, which is super important because you need to be precise with how you speak about things in math, so you need to make sure you're always using correct vocabulary to describe what you're talking about. The first word we're going to talk about is a point. A point is a location in space. It doesn't have any shape or size. We can identify it using a capital letter, for example, point A. We model it with a dot with the name of the point next to the dot. The next word is a line. A line is made up of points. It has no thickness or width. There's exactly one line through any 2 points. You name it with a lowercase cursive letter, or if you can find 2 points on the line, you can also use that to name your line. So, for example, if you are naming it with a lowercase cursive letter, it would look like this, line L. Or if you're using 2 points on the line, you can either call it line AB, or you can use this symbol for the line over top of the 2 letters. It means the same thing instead of writing out the word line. You draw a line with arrows on the ends of the line, and you put the name near the end of one of the ends of the line by one of the arrows. Obviously, a line doesn't actually have an end, but we can't draw it forever. That would be impossible. All right, next is a plane. It's a flat surface made up of points that extends infinitely in all directions. There's exactly one plane through any 3 points that are not on the same line. We can name it with a capital cursive letter, which would look like this, plane P. Or we can name it with 3 non-collinear points on the plane. We'll come back to this word non-collinear, but that would look like this, plane ABC. Usually, you draw a plane with some kind of quadrilateral. Obviously, the plane extends infinitely in all directions, but we cannot draw that in real life, so we just have to put an end on it just for visualization, and the name goes somewhere in one of those corners. All right, I told you we'd talk about collinear, non-collinear. That's what these words are. Collinear describes points that lie on the same line. Non-collinear describes points that are not on the same line. Similarly, coplanar describes points or lines that lie on the same plane. Non-coplanar describes points or lines that are not on the same plane. Make sure you know that vocab. All right, next we are going to practice this using a figure. So first one, I want you to name a line containing point W. So when I'm looking at this, a line containing point W, here's point W. It is on this line here. We can just call it line N. Now you could choose 2 other points on that as well if you'd like. So there are other options there. Next, a plane containing point X. So first what I want you to do is find point X. Here it is. Point X is on this blue plane here, which is called plane P. So we'll call it plane P. There are obviously other options. You could choose 3 non-collinear points to name that plane. All right, I want you to pause the video and try the example 1 practice problems on your own. Here are the answers. For part A, you only need to have one of these, and you can rearrange the order of these. So for example, this could also be plane ZYX or YZX, etc. These are all correct answers. Next, we are also going to today identify intersecting lines and planes. So this vocab word, the intersection of 2 or more geometric figures, is the set of points that they have in common. So the intersection, think of the intersection of 2 roads. The intersection is where the 2 roads meet. It's where the 2 roads come together, the part of the road that they share. So let's talk about this. 2 lines intersect in a point. I drew out an example there for you. Line K and line L intersect at point B here. Two planes always intersect in a line. I did my best to draw this, but you might want to go check the actual picture in your chapter book, in your chapter 1 in your book. So for example, plane R, the blue plane, and plane T, the pink plane, intersect at line J, the yellow line. Lastly, a line intersects a plane in a point. So for example, line M is intersecting plane P, the blue plane, at point A. So you could think of this as if you had a piece of paper and you stabbed your pencil through it, the paper represents the plane, your pencil represents a line. Obviously it would create one hole. The hole represents the point where your pencil is intersecting your paper. All right, let's do these examples. It says draw and label a figure for the relationship. So the first thing I'd like you to do is go ahead and plot those 4 points A, B, C, and D on the coordinate plane. Pause your video and do that. Here's what it should look like. Once you've plotted the points, connect the lines. We have line AB and line CD, so that tells you what points to connect. It also tells us that it intersects at point E, so we're going to name this point of intersection E. And it also tells us point F is coplanar with these points, but not collinear with line AB or CD. So coplanar means it's on the same plane, so this is a coordinate plane. We can put it anywhere on this coordinate plane. However, it is not on line AB or CD. Not collinear means it's not on those lines. So you can put point F anywhere you want. I'm just going to pick this random point 2, 8 to place point F. But you can put it anywhere on the coordinate plane as long as it is not on one of these lines. Next, we have QR intersects plane T at point S. So the first thing I draw is plane T. Label it in the corner. Next, we have QR. This is a line. So line QR. We want to make sure it goes through the plane because it's intersecting the plane. So we draw the rest of the line dotted because it's technically on the other side of the plane. You wouldn't be able to see it. So line QR. So we need to make sure we put points Q and R somewhere on that line. It doesn't matter where you put them. However, the point where it's intersecting plane T must be called point S. I'd like you to try these practice problems below. Pause the video now. Okay, check your answers. Make a note on this one point on part A. Your point L could have been anywhere on that pink line. As long as it has a y value of 2, it would be collinear with J and K. All right, last example for today. We are going to use this figure to answer these following questions. So, how many planes appear in the figure? Let's count them up. We have this one. Then we have this three-dimensional figure. So we have, whoops, why did I skip to 2? 2. Plane 3 is in the back. Plane 4 is over here. Plane 5 is in the front. Plane 6 is in the very, very front. So there are 6 planes altogether. This three-dimensional shape alone has 5 planes. The bottom of the 3D shape is the same as plane X, so we don't count that twice. Next, name any 3 points that are collinear. I immediately saw these 3 points here. They are all on the same line, so I would call them points J, K, and D. Next, name the intersection of plane HDG with plane X. So let's find HDG. That's this front face here, this plane. Where does it intersect plane X, which is the plane at the bottom? It intersects, remember, 2 planes always intersect in a line. So that would be this line here. And we call that line HG. Finally, at what point do lines LM and EF intersect? Explain your reasoning. So LM is this line here. EF is this line here. Where do those two lines intersect? Well, they do not intersect because they do not share any points. All right, pause the video, try the practice problems below. Okay, check your answer. For part A, you need to give me the answer. This is your question of the day. Part B, at what point or in what line do the planes JDH, JDE, and EDF intersect? Well, JDH is this plane here. JDE is this plane in the back, that face, and EDF is this face over there. All of these three faces, these three planes, all share point D. They all have point D in common, therefore point D is their intersection. That's all I have for you today. Have a great night.